averaged over the entire populace of the Northern Hemisphere in the year of the accident in 1986. Debate. The nuclear power debate concerns the controversy which has surrounded the deployment and use of nuclear fission reactors to generate electricity from nuclear fuel for civilian purposes. Proponents of nuclear energy, regarded as a sustainable energy source that reduces carbon emissions and increases energy security by decreasing dependence on other energy sources that are also often dependent on imports. For example, proponents note that annually, nuclear-generated electricity reduces 470 million metric tons of carbon dioxide emissions that would otherwise come from fossil fuels. Additionally, the amount of comparatively low waste that nuclear energy does create is safely disposed of by the large-scale nuclear energy production facilities, or it is repurposed, recycled for other energy uses. M. King Hubbert, who popularized the concept of peak oil, saw oil as a resource that would run out and considered nuclear energy its replacement. Proponents also claim that the present quantity of nuclear waste is small and can be reduced through the latest technology of newer reactors, and that the operational safety record of fission electricity in terms of deaths is so far unparalleled. Karicha and Hansen estimated that global nuclear power has prevented an average of 1.84 million air pollution-related deaths and 64 gigatons of CO2 equivalent GTCO2 greenhouse gas GHG emissions that would have resulted from fossil fuel burning, and if continued, it could prevent up to 7 million deaths and 240 GTCO2 emissions by 2050. Proponents also bring to attention the opportunity cost of using other forms of electricity. For example, the Environmental Protection Agency estimates that coal kills 30,000 people a year as a result of its environmental impact, while 60 people died in the Chernobyl disaster. A real-world example of impact provided by proponents is the 650,000-ton increase in carbon emissions in the 2 months following the closure of the Vermont Yankee nuclear plant. Opponents believe that nuclear power poses many threats to people's health and environment, such as the risk of nuclear weapons proliferation, long-term safe waste management, and terrorism in the future. They also contend that nuclear power plants are complex systems where many things can and have gone wrong. Costs of the Chernobyl disaster amount to $68 billion as of 2019 and are increasing. The Fukushima disaster is estimated to cost taxpayers $187 billion, and radioactive waste management is estimated to cost the European Union nuclear operators $250 billion by 2050. However, in countries that already use nuclear energy, when not considering reprocessing, intermediate nuclear waste disposal costs could be relatively fixed to certain but unknown degrees, as the main part of these costs stems from the operation of the intermediate storage facility. Critics find that one of the largest drawbacks to building new nuclear fission power plants are the large construction and operating costs when compared to alternatives of sustainable energy sources. Further costs include ongoing research and development, expensive reprocessing in cases where such is practiced, and decommissioning. Proponents note that focusing on the levelized cost of energy, LCOE, however, ignores the value premium associated with 24/7 dispatchable electricity and the cost of storage and backup systems necessary to integrate variable energy sources into a reliable electrical grid. Nuclear thus remains the dispatchable low-carbon technology with the lowest expected costs in 2025. Only large hydro reservoirs can provide a similar contribution at comparable costs, but remain highly dependent on the natural endowments of individual countries. Overall, many opponents find that nuclear energy cannot meaningfully contribute to climate change mitigation. In general, they find it to be too dangerous, too expensive, to take too long for deployment, to be an obstacle to achieving a transition towards sustainability and carbon neutrality, effectively being a distracting competition for resources, i.e. human, financial, time, infrastructure, and expertise. For the deployment and development of alternative, sustainable energy system technologies, such as for wind, ocean, and solar, including e.g. floating solar, as well as ways to manage their intermittency other than nuclear baseload generation, such as dispatchable generation, renewables diversification, supergrids, flexible energy demand and supply regulating smart grids, and energy storage technologies. Nevertheless, there is ongoing research and debate over costs of new nuclear, especially in regions where seasonal energy storage is difficult to provide and which aim to phase out fossil fuels in favor of low-carbon power faster than the global average. Some find that financial transition costs for a 100% renewables-based European energy system that has completely phased out nuclear energy could be more costly by 2050 based on current technologies, i.e., not considering potential advances in e.g. green hydrogen, transmission and flexibility capacities, ways to reduce energy needs, geothermal energy and fusion energy, when the grid only extends across Europe.